Hey guys, Beacon here. Let's look at problem A1 and A2 from the most recent Codeforces round, Gardner and the Capybaras. To start, when you remove the cool story and the padding from the question essentially becomes, you're given a string of the letters A and B. You want to split the string into three sections, so three consecutive sections, so that the middle section is lexicographically smaller than or equal to the first and last ones, or it is lexicographically larger than or equal to both of them. If you're not familiar with the word lexicographically, it's basically like how words are ordered in the dictionary. You check from the first position, the leftmost letter, you check one by one until you get to a position where the letter in the one word appears later in the alphabet than the letter in the other word, in which case the word with the letter that is further down in the alphabet is the larger string. Or, case 2, you keep on matching and it's the same letter each time until one of the words runs out of letters, in which case the word with letters left over is the larger string. And of course, if they're the exact same string, they are lexicographically the same. Now, the first thing you should try here is to think, what does the question exactly want? Well, it wants the middle section of the string that you split to be lexicographically larger than or equal to, or smaller than or equal to both of the other pieces. That means that the middle string is either the maximum or the minimum of the three substrings. Wait a minute, that means that if we perhaps find the smallest possible string that can appear in the middle string, perhaps that will always work because the smallest possible string will obviously be smaller than any other string, so it will be smaller than the other two. Likewise, if we perhaps make the middle string the largest possible string, we could perhaps make it the maximum because the largest possible string would obviously be larger than the other two strings that we made. So, we try this out. Imagine we sort all the possible strings of maximum length n that we can make with A's and B's, as if we would arrange them in a dictionary. What is the first thing that appears? Well, that's easy. It's a string A, just a letter A. The string that would appear last, on the other hand, would be the string with n B's. Now, realize that if you can perhaps find the letter A in the middle of the string, we can just make that be the middle string and we're done, because that is the smallest possible string, so that will obviously be smaller than what we can make in the first section and the last section. Similarly, if there are no A's in the middle, that means that the entire middle part of the string will all have to be B's, in which case we can just take that entire middle part and that will be bigger than or equal to the first section and the last section, which will just be one letter each. Now, lucky for us, once we make the observation at the beginning, this question is very easy to prove and to convince yourself. Of course, no non-empty string can be lexicographically smaller than an A, so if we can find the letter A in positions 2 to n-1, we'll be done, as we can just take the first section, the A, and the last section, and the A will be smaller than both of them, or equal to. If we cannot find such an A, this means that the positions from 2 to n-1 will have to be B, because if there is no A, each position has to have either an A or a B, so all of them are B's. This means that we can just take the string formed from position 2 to n-1, which will consist of n-2 B's. And since there are at least 3 letters, any string that has one or more B will be bigger than or equal to the other two, because the first string will just be a letter and the last string will be a letter. Both of them will either be an A or a B. So at most there can be a B, which is equal to perhaps the smallest possible thing in the middle, which will be a B. And any other largest middle string will obviously be larger than the other two. Coding up the solution is pretty easy as well. I'll be using the language Python to demonstrate how to implement this solution. First, we take an input as a string s, then we create a variable flag, which we set as false. This will be used later. Now we create a for loop from 1 to length of s minus 1, which will loop through the positions 2 to n minus 1 in the string. Now we check, is the position A? If the position is A, then we can basically use Python string slicing and print out the first section, the A, and the last section. And we set flag as true to indicate that we have found a solution, and we exit the loop. And we keep on doing this for all the middle terms. If we find no B, then the flag will not be set, so if not flag, then we'll print out S0, which is the first letter of the string, then S1 to -1, which is the second to the second last letter of the string, which will be the middle section of all B's, and then the last S-1, which will be the last element. And this is how you solve this problem. I really hope you enjoyed this problem, and stay tuned for more interesting and cool problems. Thank you.